Hey everyone, today we are going to build an incredible application, okay, an AI agent that combines the power of RAG with the documents, okay, yeah. So by end of this video, you will have a working AI agent that can answer questions based on the content of any PDF that you provide, okay, yeah. So I just mentioned using RAG, okay, and you can see on the screen also we are going to building chat with PDF using RAG, okay, yeah. So why we need RAG? So I think we need to first understand what kind of challenges we are facing. That's we choose RAG, okay, yeah. So let's first understand the problem statement, okay? Yes. So let's assume you work for a business, okay? And that business has a lot of data in the PDF format on the databases, Excel files. As of now, just consider PDF files, okay? You can see on the screen we have a lot of data, like we have 1,000 of files, okay? Yeah. So as an example, just imagine you have a many PDF file, okay? Yeah, you have imagined, okay? The business say to you like, hey, we have a huge amount of data. It's very hard to read word by word manually to see what content is available in which file and where. Of course this will require a lot of manual effort, okay, yeah. Now they can ask you like, hey, can you build an AI agent? Since we have a lot of data and many employees, we don't want them to go through each document manually one by one, and it's a too time consuming, okay, yeah. So instead of that, they should be able to ask an LLM question and get answer from the available documents, okay, yeah. So essentially what he trying to say, like you have to find a way to tell any LLM that you have a specific set of files so it can answer queries related to those documents only, okay, yeah, okay. So now you understand the problem, okay, what problems are business facing, okay, yeah. But the challenge when we trying to build in the real world, okay, the challenge we are facing, like LLM has no knowledge about our private data, okay, it only train on the public data. And the second one, if we have a lot of data, okay, like you have a lot of data, you cannot feed all those data directly into the LLM because every LLM has some own limited context window, okay, yeah. So these two challenges we are facing, okay, yeah. So using RAG we can resolve these challenges, okay. How? So for that, let's now we understand what is RAG, okay. So basically it's a technique, okay. RAG is a technique that allows a LLM to access external knowledge sources during the generation process, okay. So instead of relying on their training data, these models can retrieve relevant information from documents, databases, or other sources to provide accurate, up-to-date answers, okay, yeah. So using RAG, we are going to tell our LLM, hey, you have I provide you some external resources, you have to give answers from that documents only, okay, yeah. So in our case we will be using PDF files as our knowledge base, okay, yeah, okay. So now we understand what kind of problem, basically what kind of challenges we are facing and what is RAG, how RAG will solve problem, okay, yeah. So we can build in two way, okay. The first solution is, of course, it's a brute force solution, okay. What we can do, let's just scroll, okay, yeah. So what we can do, this is a very naive approach, okay, yeah. Like we have a PDF, okay, like some PDF, we have a lot of PDF. What we can do, just extract all those text from that PDF, okay, and we can say any LLM like, hey, you are an AI assistant which can help user talk to their data, okay, and inside available data you have to just pass that text which you are extracted from the PDF only, okay, yeah. So now user can ask, like there is a lot of user comes and, hey, tell me about this query, and of course you will respond like, hey, this is what I got in available data, okay, yeah. So it will work definitely, okay, it's a first solution. uh, if it will work, but if it is working, why we need RAG, okay, yeah. It is working only for the small PDF, okay, like we have a PDF who have only which have only two to three pages, okay. In that case it is good, no need to move RAG for this only, okay, yeah. But what is the problem here, like we have a lot of data, like if we have a very large file, okay, that have like 1,000 of file and each file have 1,000 of pages and a lot of data, okay. In this case, if you extract all those text, okay, and you pass directly to LLM, it's a very costly, okay. Maybe you are under limitation of the context window, but again it's a very costly, okay, yeah. Our second one is the, once you have a lot, basically maybe you exceed the limit of the context window, okay, that is again problem, okay, yeah. So it's working for only when you have some small files, okay. Yeah, so that's why we need RAG, okay. Yeah, so the best approach using RAG, okay, of course, okay. Yeah, so what RAG say, you have to perform two phases, okay. You have to work for the two phases. First is the indexing phase and the second one is the retrieval phase, okay. In the indexing phase, what you are going to do, when users some provide data, okay, we are going to use that data to store somewhere, okay. Yeah, perform some data, okay. Yeah, basically perform to store that data. And in retrieval phase, we have to just query, like user ask any query related to that document, you have to just find that response related to that query and give them response, okay. Yeah, so of course these two are completely different to each other, okay. Yeah, let me explain. Once I explain to you, okay, you will get the clear understanding what I am trying to say, okay. Yeah, so this is the indexing phase, okay. Yeah, so what problem we are facing in the previous approach, okay, like if we have a lot of data, okay, and of course we extract that text is a lot, okay, that text maybe it will exceed the context window, okay, we cannot directly pass, okay. So instead of directly passing to LLM, what we can do here, we can do basically we split that data into some small chunks, okay. Again, there is a multiple way to splitting, okay. Yeah, of course you can do page level, page by page, like if any PDF have a 100 page, okay, then you can just split that one by one, okay, one page by page. And second one is that you can split in the paragraph level, okay. Again, you can split any kind of logic, okay, it's up to you, okay. Yeah, so instead of directly pass all the data to LLM, what we can do here, we can chunk, basically we can split those data into some small chunks, okay. Yeah, so yeah, this is okay. Again, after chunking, of course we are not going to just combine all those chunks and just pass to, no. So what we are doing here, just use a embedding model, okay. Using that embedding model, what we are going to do here, just give all those chunks to a embedding model. That embedding model will generate a vector embeddings, okay. There are multiple vector embeddings, okay. Yeah, and that vector embeddings we are going to store inside a vector DB, okay, in the vector format. And every vectors have some metadata, has some info, like we are splitting in the by page level, okay. So every vectors have some page number and some documentation, okay, sub docs, okay, sorry, not documentation, document, okay. Yeah, some part of content, okay. Yeah, so what is the indexing phase? We have a lot of PDF, just extract all those text, okay. What not extract, okay, just split all those document into some small chunks by page level or by paragraph level. After that, we have to just pass that chunks into an embedding model. That embedding model will convert these chunks into a vector embeddings, and that vector embeddings will gonna save inside a vector DB, okay. Yeah, so this is our indexing phase, okay. Now we have every information with some small chunks in the vector DB, okay. Yeah, so okay, let's explain the retrieval phase, then you will get the clear understanding, okay. Yeah, so for the retrieval phase, okay, of course user give a query, we will use same embedding model, okay. Yeah, let me explain what happened here, okay. Like user give us some query, hey, can you explain me what is node.js, okay. Like we have take the PDF of node.js, okay, example of the node.js, and we just split into lot of chunks, and that chunks pass through the embedding model. That embedding model convert into vector embeddings. That vector embedding is stored in the vector database, okay. Like query is coming like what is node.js, okay. So what happened here, we can be we can directly pass to the LLM, hey, can you answer me this? No, still our LLM don't have any kind of information about our private data, okay. Yeah, if we are expecting like our LLM give answer from our private data, still we are not giving him, like we are just storing all those data into lot of chunks, basically vector formats with some metadata inside a vector DB, okay. Yeah, so again, what we can do here, we are getting some query, okay. Again, what we do here, just convert this query into a vector embedding, okay, using that embedding model which we used in the indexing phase. So after that, that vector embedding, what happened here, the query will convert into vector embedding, okay. So what happened here, that will be very easy to search. So before passing to our query to our LLM, what we are going to here, we are going to perform some similarity search on our vector DB, okay. So what happened here? Now we have a vector embedding. So we are perform some similarity search it to our vector database, okay, vector DB. So what happened here? Like when we are chunking in indexing phase, okay, like we have a 50k of chunks, okay, but user provide any query like what is Node.js, that will only relevant with the two chunks, okay. So what we will get here, we will get the two chunks only, okay. So what happened here? You know, the context window size is very small, of course. So what happened here? Now we can just pass that chunks with the user query to our LLM, okay, any chat LLM, and then that will respond to from our available data, and we will get the exact answer, basically proper answer with the metadata like, hey, I'm getting that response from this page number, okay. And yeah, so this is a total way, this is the rack pipelines, okay. Using this we can easily basically chat with any kind of file, okay. No matter it's the file is a 1 GB 2 GB, doesn't matter, okay. We can easily chat with that PDF, okay. Yeah, so using this way we can chat our PDF, okay. Yeah, so first one is the indexing phase and second is the uh, retrieval phase, okay. So I hope you got the clarity how we are going to implement, okay. Of course, when we are going to starting implementation, we need a few more things, okay. Yeah, but again that is the code level, but I think and the high level how with the architecture how we are going to move, okay, how things are working, I think you got the clarity, okay. Yeah, so let's start coding, okay. Yeah, so we already discussed, okay, in our case we will be using PDF files for our knowledge base, okay. Yeah, and our application will have two phases. First one is the indexing phase, the second one is the retrieval phase, okay. In the indexing phase, what we are going to do, we are going to process PDF and store them into a vector databases, okay. In the retrieval phase, we are going to just get a query and convert that query into vector embedding, and using that vector embedding search a similarity search, we will get some chunks. Using that chunks we will call a GPT, basically a chat model, okay, that will we will get the response from that, okay. Yeah, so these two phases, okay. Yeah, so for this project, of course, we will be using Python as our primary language, okay. I would be needing a LangChain, okay. Why we would need LangChain? Okay, so like we need a read documents, okay, from file, okay. So LangChain have a utility function for this, okay. Yeah, okay. So now we are just basically read the documents, okay. What we need to do next? We need to next basically split that document in a various way, like you can do page by page, you can do paragraph by paragraph, okay. It's up to you, okay. But for this also a utility function available on LangChain, okay. We need to connect our vector databases. For this also there is a utility function available on the LangChain, okay. So a lot of functionality already given by LangChain, okay, that of course made our life very easy, okay. Yeah, so yeah, we are going to use that, okay. Yeah, so I love to code inside isolated system, okay. So our first step is to create a virtual environment for that, okay, and then we will be moved in the second step, we'll connect our vector databases, okay. And yeah, there we go, we will start our indexing phase. After that we will start retrieval phase, and there we go, okay. Yeah, so first we need to create a virtual environment, okay. For that, what I need to do here, just we need to run a command, and the command is python -m. Let me just, okay, sorry, okay, okay. So python -m venvrag, okay, rag, okay. You can give whatever name you want, okay. I just give a rag, okay. Okay, yeah, just hit enter and wait for that, okay. Yeah, okay. So now our virtual environment file is ready, okay. What we need to do next, we need to just activate this environment, okay. For that we can directly run activate rags script and activate, okay. This will work for Windows, okay, but for the Mac and Linux you have to append a source, okay, before this command, okay. Yeah, that will work fine, okay. Yeah, no issue. Now we have our virtual environment, okay. Our step one is successfully completed. Okay, our second step is we are going to set up our vector DB. Okay, so for the vector DB I am gonna use Qdrant DB. Okay, there's a lot of database available on the internet, you can use whatever. Okay, but I am going to use Qdrant DB. Okay, the installation process is you can directly go to the Qdrant websites and you can download. Okay, directly the second way you can use a Docker. Okay, so I am following the second way. I'm just going to write a compose file for that. Okay, and using that I'm just pulling that image inside my system. Okay, yeah. So if you don't have installed Docker, so please install Docker and then come back to video. Okay, yeah. So let's first create a document file. Okay, Docker compose file. Okay, sorry. So Docker compose.yml. Okay, yeah. It will have services. Okay, yeah, it will have services. Inside the services what we have to tell like, hey, we are going to use vector DB. Okay, yeah, and inside the vector DB we are going to use Qdrant DB. Okay, yeah, so we need to tell him the image name. Okay, so the image name it's a Qdrant DB. Okay, yeah, and for the port we are going to use 6333. Okay, yeah, no issue. Yeah, so what we need to do next, this is our total compose file. Okay, for the vector DB, basically Qdrant DB. Okay, yeah, so what I need to do next, we need to just pull this image. Okay, so I just run a docker compose up -d. Okay, you can see here a container is already running. Okay, so I already have my Qdrant DB in my system. Okay, so in my case it's just give me a message like, hey, already running. Okay, yeah, in your case it will take some time, maybe it will take 1 2 minutes 3 minutes. Okay, it's totally depend on your internet. Okay, yeah. So now we have running our vector database. Okay, Qdrant DB, let me show you. Okay, so this is our vector database. Okay, let me just back. Okay, yeah, so just open this. Okay, yeah, you can see the port is 6333. Okay, which we declare inside our compose.yml file. Okay, yeah, so also we can see on UI as well. Okay, yeah, this is port, you can directly open on the dashboard. Okay, yeah, so this interface is coming. Okay, once you open this port on your localhost. So what happened here, you can see here there is a collection tab. Okay, inside collection, when you are ready to basically, when you upload your chunks to our vector database, inside collection you are going to basically, you can see here. Okay, yeah, you can view here all those collection whatever you are save inside vector database. Okay, yeah, so it's a very easy way to see, and yeah, it's a very good UI. Okay, yeah, so now we have our database. Okay, yeah, still we haven't connected to yes, but no, at least now we have our databases and it's a running state. Okay, yeah, so our second step is also completed. Okay, third, so what we need to do, of course, the bean will start our indexing phase. Okay, so in the beginning what we need to do, we need to basically first load our document. Okay, so there is a utility function available on the LangChain. Okay, so let's first write some packages. Okay, we need some path lib. Okay, from, we don't need any explicitly download any kind of library. Okay, so we take a path from here. Okay, yeah, also we need to API key for the chat, basically for the OpenAI. Okay, let's park it for later. Okay, let's park it for later. Okay, yeah, so using path we can load documents. Okay, yeah, so let's, like, I create a PDF file. Okay, PDF file equals to, just take a path here. Okay, and inside what we can do here, just file. Okay, yeah, I think, okay, it's coming on the file, go to that parent. Okay, go to that parent, and what we can do here, just open, I'm going to use a file, the name of that file is MongoDB. Okay, mongoose.pdf. Okay, yeah, let's bring it here. Okay, so in this file what I have a lot, basically it's have a multiple PDF. Let me just open it. Okay, okay, I think I have downloaded here. Let me just open this PDF. Okay, okay, where is this? Okay, yeah, you can see here this PDF have lot of pages. I think it's not have lot of pages. Okay, let me open another file. Okay, no issue, let me open another PDF. Just, okay, let's search anything. I think I have okay, Docker. Okay, Let's directly download from online, okay? No issue. Let me download a PDF which have a lot of pages, okay? No issue. PDF Node.js, okay? Let's download Node.js. Sorry, I think I get it wrong. PDF docs. Okay. No, I'm getting wrong. Okay, Node.js tutorial. I need to write tutorial. Okay, Node.js tutorial PDF. Okay, Node.js tutorial PDF. Okay, now just download. I think it's a PDF only. Okay, yeah. So you can see here it's a have a 125 pages. Okay, so I'm going to download it here. Okay, just I download it here, and okay, I need to save. Yeah, it's directly open here. So no, I can. I have made another page. Okay, yeah. Okay, inside I can save it here. Okay, yeah. Now you can see here we have a lot of pages here. Okay, so I am using this PDF for the chatting. Okay, yeah, you can use another PDF, it's up to you. Okay, no issue. So let me just see here. Okay, the PDF is coming or not. Okay, yeah, you can see here there's a PDF available. Okay, yeah, let me just quickly delete this from here and just note this. Okay. Okay, so what I need to change here is the node.js.pdf. Okay, node.js PDF. Now we have our PDF file. Okay, what I need to do next, of course I need to load this file. How we can load this file? Okay, so using we need to use LangChain, okay, for the utility function. So let's just search for the um, LangChain, okay, for the LangChain document loader. Okay, yeah. So you can see here there is a lot of things available, okay, but we need only focus on the PyPDF because there is a lot of like unstructured Amazon text we can use here, but yeah, we are going to use PyPDF only. Okay, yeah. So you can see here the notebook provide a quick overview for getting, okay, document loader, no issue. I don't, okay, yeah. So for the installation process, okay, first we need to install this. Okay, so let's just paste it here and hit enter. Okay, yeah. Sorry, I need to remove this module operator from. Okay, yeah, no issue. Okay, so it is provide us a utility function. Okay, you can see here, just go down below, we have a PyPDFLoader. Using this we can directly pass our basically pass a PDF, and that PDF will load using this utility function. Okay, yeah. So what I need to do next, we need to just copy this from here. Okay, yeah, and just paste it here, of course. So let me just bring it here. Okay, issue, and just move it here. Okay, yeah. So what I need to do here, we have a file path. Okay, so just assign this here a PDF file here. Okay, okay, so now we can load this PDF and just go down. Okay, yeah. So now we have this. Okay, how we can load this? We can directly loader dot load. Okay, this loader dot load and docs of 0. We can print this here. Okay, yeah. So just what I'm going to do here, docs equal to loader dot load. Okay, yeah. Sorry, okay, yeah. Okay, so let's print this document. Okay, okay, it's already suggesting me. Okay, let's print this. So let me wait. I think it's still not downloaded. Okay, yeah, it's still in the running state. Okay, yeah, let's wait for the download process completion. Okay, yeah. So it's taking too much time. Okay, no issue. Let's wait for. Okay, so you can see here it's a download complete. Okay, yeah. So now we can print this page component. Okay, you can see here the file path. Okay, what I need to do here, just remove this. Okay, yeah, I don't need this, man. Okay, yeah, the PDF file, we can directly pass the PDF file here. Okay, yeah. So let me just run this. Okay, and check we are able to print or not. Okay, so python.index.py. Okay, so you can see here a PDF reference of the complete Node.js dev course, the version 3.0. Okay, we just print the first content. Okay, so now we are able to load our PDF. Okay, yeah, that's good. What I need to do next, I need to basically just split this document. Okay, basically yeah, we are able to load docs. Okay, next we need to do basically split. Okay, yeah. So again there is a utility function available on the LangChain. Okay, so what we can do here, just search for the text splitter. Okay, text splitter on LangChain. Okay, yeah. Okay, you can see here. Okay, so what I need to do here, pip install LangChain text. I'm going. We need to install this. Okay, let me just install it here. Okay, yeah, and you can see here the text editor is a break large docs into a smaller chunks that will be retrievable. Okay, it makes our lot of life easy. Okay, if it's not available, we need to write up functions from the scratch. Okay, think about like you want to basically chunks split these files. Okay, in some other format, maybe you want page by page or paragraph by paragraph. Okay, that will be very tough to us. Okay, yeah, of course we can do it. Okay, if it's not available, that is the only way. But yeah, it's make our life very easy. Okay, okay, so requirement already satisfied. Okay, I think with the LangChain community it's already coming. Okay, let me just check. Okay, okay, yeah, still we are not free our requirement. Okay, no issue. So what we can do here, you can see okay, for the splitting this, we need to LangChain text splitter from the recursive character text splitter. Okay, yeah, you can see there is a lot of way. Okay, let me just quickly. Okay, there's a recursive way. I think there's another way also available. Okay, yes, you can see here there's a character text splitter, and I think yeah, so as of now we are only okay, there is a character text splitter. Okay, and there is a recursive. Okay, anyway, we are going to use recursive character text splitter. Okay, yeah, no issue. For that we need to import this. Okay, yeah, so just copy this and paste it here. Okay, no issue. A lot of time you can see here we are going to copy and paste from LangChain a lot of things. Okay, yeah, so of course we need to first import this. Okay, and just copy it from here, Control X, and remove it. This is no longer needed. Okay, yeah, so for the text splitter we can say like yeah, our chunk size is 100 and chunk overlap. Okay, what do you mean by overlap? Like you have split your PDF into paragraph, okay? Maybe a paragraph like have a 500 character, okay, and you just decide 400 character. So maybe a lot of time or paragraph maybe have 1,000 word, okay? So some part of the paragraph is another chunks and there is some part of paragraph is another chunks, okay? Of course this condition will come, okay? So for that there is another way, there is a chunks overlap, okay? On the each 400 character basically you have to overlap. It will check if it is happen. Of course it will help to similarity search, okay? Yeah, so it's already handled by LangChain, okay? No issue. So you can see here, let me just add it here, okay? I'm going to chunk size the 500 and chunks overlap I am going to use a 400, okay? Yeah, or we can search, let me search, okay? I think I not give you clear understanding about this, okay? Yeah, so the chunk size, okay, let me just directly search chunk overlap part in LangChain, okay? I think it's what is chunk size and chunk overlap, okay? Yeah, so you can say chunk size refer to the maximum number of character or token allowed to a single segment of text, okay, when breaking a large document into smaller parts, okay? Yeah, chunks overlap is the number of character or token shared between consecutive chunks, okay? This ensure context continuity so that important information spanning chunks boundary is not lost. Example, chunk size 40 and overlap is 10, okay? Yeah, now you got the clear understanding, okay? Yeah, so using this we can basically split our documents, okay? Again we need to pass here the docs, okay, not document. So just pass this here, okay? Yeah, so inside text we are getting all those basically all the chunks here, okay? Yeah, again what we need to next here, we need to basically we need a vector embedding, okay? Using that basically an embedding model, using that embedding model we will convert these chunks into a vector embedding, okay? Yeah, so what I need to do here, I just pass these docs, okay? Yeah, and again I need to write here, okay, just a document, let me just document, or either we can directly pass docs, okay? No issue at all, okay? Yeah, so now I need some vector embedding, okay? So for that let's write embedding model, okay? Yeah, embedding model equal to, we need a OpenAI embedding, okay? Yeah, so let me just search OpenAI embedding, LangChain OpenAI embedding, okay? Yeah, okay, so you can see here where we can get our OpenAI embedding, okay? It's a LangChain OpenAI, okay? I think it's not installed yet. Okay, let me just quickly, okay, let's first freeze our requirement, okay? I think then we can see. So for the freeze, pip freeze, okay, pip freeze requirement dot txt, okay? Yeah, oh I write a mistake, okay, here. So pip freeze, it's a JD, okay, and we need to write it, not a V. Yeah, of course I forgot. Requirements.txt. Okay, again I made mistake, okay? No issue. Yeah, it is okay, no issue. Whenever file we can write, okay? Yeah, you can see here on the requirement.txt, okay? No issue, just rename it, not an issue, okay? Yeah, so I think we have already our LangChain OpenAI, okay? You can see here we need to install pip install -q LangChain OpenAI, okay? I think we have already, when we install LangChain community, I think we get all, okay? Let's search for that only, okay? LangChain, if not, no issue, we will install OpenAI. I think OpenAI, no, we don't have, okay? No issue, we don't have. Let's quickly install this, okay? Yeah, no issue. What we can do, just copy this and paste it here. Okay, so in the meantime, what we can do here, okay, so for that, let's just copy it from here. Okay, yeah, for the embedding model, let's copy it, and okay, yes. So okay, I have to move it from, okay, yeah. Now we have a LangChain OpenAI, okay, from the OpenAI. Basically, we have our OpenAI embedding, okay, yeah. So here I'm going to use text embedding 3 large, okay. You can use, there are a lot of models available, okay, yeah. You can use whatever you want, okay, yeah, no issue. So this is our embedding, okay, yeah. I think our install is successfully, okay. Let's wait, okay, it's still installing, okay, no issue. Okay, so let's see our next step. Okay, now we have our embedding. Okay, yeah. So what we need to next here, we need to convert these basically chunks into vector embedding. Okay, yeah, simple. Okay, let's see it's downloaded or not. Okay, it's still sorry. Okay, no issue. So what happened here, now we have our embedding models. Okay, we have our chunks ready, we loaded our documents. Okay, everything is available. Okay, what we need to next here, we need to just connect our databases. Okay, basically vector db, and we directly told him like, hey, in this collection name use this embedding model, and these are the chunks, save it as a vector. Okay, yeah. So again, we LangChain already have a basically a utility function to connecting the Qdrant db. Okay, yeah, so let's search for that. Okay, so I can just search directly. Okay, Qdrant db LangChain. Okay, you can say LangChain. Let me see. Yeah, so Qdrant with LangChain, you can see here Qdrant with LangChain. So we need to just install this. Okay, yeah, I think it's okay, it's installed. Okay, let me install this as well. So Python installed -q LangChain Qdrant. Okay, so after installing, what we need to do, you can see here, yeah, again, of course, it's LangChain OpenAI, we have that only. Okay, no issue. Okay, so from the LangChain Qdrant, we can get our Qdrant vector store. Okay, using this store, we will be connecting our local database and store our chunks inside, basically store all the vectors inside our vector database. Okay, yeah, let's just copy from here. Okay, yeah. Okay, sorry, not here, Control Z, we need to paste it here. Okay, and you can see here, what I need to do next here, we need to just copy this from here, and again, okay, no issue, paste it. Okay, in the vector store, what we need to do basically, we need to remove this client. Okay, I don't need this. Okay, I need to tell him like, hey, these documents we have. Okay, so on the documents, okay, documents, we have text. Okay, yeah, that's good, it's already detected. Okay, yeah, let me create a collection name, suppose a demo collection. Okay, it's up to you, whatever you can. Okay, yeah, also we can or give embedding model, so already given. Okay, embeddings. Okay, yeah, and what we need to do, we need to told him like, hey, use this URL. Okay, so now we have our Qdrant db running on our localhost. Okay, on the port of the 6333. Okay, yeah, okay, I think it's still installing. Okay, yeah, it's installed. Okay, no, oh, it's still installing. We install LangChain, no issue. Okay, so let's wait. Yeah, it's installed. Okay, yeah, let's quickly freeze the requirement. Okay, and okay, no, so where is this? Okay, and let's correct it. Okay, Done. So now we have everything, okay. Using this PyPDFLoader, we able to load our documents. Using this text splitter, we are split our docs into chunks, okay. Using this OpenAI embedding, we will convert into our vector, basically vector embeddings, okay. And these vector embeddings, these vectors we will store inside our database, okay. Qdrant DB, using this Qdrant vector store, okay. Yeah. So okay, now everything is ready, but there is a missing one thing, okay. For the OpenAI embeddings, we need API key, okay. So for that also we need to install a .env, okay. So pip install .env, and we need to import, okay, from .env, import load env, okay. And before we doing anything, just load that environment, okay. Or let me create a env file .env. Inside .env you have to paste your API key, okay. So I just paste my API key. Yeah. Okay, let's wait for the installation, okay. No issue. Okay, so it's installed successfully, okay. And your key is like okay, let me show you. I don't want to show my API key, okay. You can see here open API key, OpenAI underscore API underscore key, okay. This key, and you will get this API key from the OpenAI platform, okay. Yeah. So now we have all those things available, okay. Let me see everything is working fine or not, okay. Yeah. So let's just run this, okay. Okay. Okay, so there is just some mistake here, okay. What we done, okay, the text splitter split text, okay. Yeah, on the line number 15, okay, we pass the docs here. Okay, I think I need to write here a documents, okay. Let me just quickly documents equal to doc, okay. Yeah, and okay, now run. I think error is gone, okay. Keyword argument documents, okay. Recursive character text splitter dot split text got an unexpected keyword argument documents, okay. Okay, let me change, okay. I can see here I'm getting the text, okay, from this okay, sorry, I need to split documents, okay. Yeah, so here what we need to do, we need to split documents. Sorry, I made a mistake here. Nice. Okay, now it will working. Yeah, okay, hope everything is okay. Yeah. Okay, again I have made a mistake, okay, that the vector is stored, the URL got unexpected keyword augment documents, okay. Yeah. Okay, again I need to change something, okay. I directly use here from the Qdrant vector store, okay. I need to told him like, hey, from documents, okay, sorry, from documents. Okay, Now it's work. Okay, of course now it will work. Yeah. Okay. Okay, so you can see here our demo collection is available here. Okay, yeah, no issue. It's working. Actually, we haven't write any kind of console like ours. Basically, indexing process is completed. Okay, that's why we are not getting it. Okay, you can see here on the UI. Okay, the demo collection is available. Okay, there is a point approx 384, 4 segments and 1 short. Okay, yeah. So just open it here. You can see that all the chunks here available. Okay, yeah, all the chunks available, and you can see if I just there's a payload. Okay, you can see here there's a page content. That's okay. There is some metadata. Okay, inside that metadata, the page number, page label, everything is available. Okay, so once you give a query like, hey, I want this, so it will respond you with the metadata also. Okay, that on this page number you can go and read the entire documents. Okay, yeah. So now we successfully created our indexing phase. Okay, now we need to move our retrieval phase. Okay, yeah. So hi, let's start with the retrieval phase. Okay, so for that retrieval phase I have created a file chat.py. Okay, yeah. So here we will need a lot of things from, we can copy a lot of things from our indexing phase. Okay, yeah. Of course we would be needing our embedding, because as we discussed, okay, once the user give a query, okay, so we will convert that query into embedding. Okay, so for that we would be needing that embedding model. Okay, yeah. And also we need a connection of the databases, so both things are needed here. Okay, yeah. And okay, let me just copy this first. Okay, also we would be needing our .env. Okay, yeah. So just paste it here. Okay, yeah. And again okay, and for that we can directly copy our embedding model. Okay, so that embeddings here. Okay, and also we can copy our vector store. Okay, yeah. Okay, we need to change a lot more, like here what we need to change. Okay, let me just, okay, so from documents, now we need to do what, from the existing document. Okay, from the existing document. Okay, from existing collection. Okay, from existing collection we need to told him like, hey, this is our embedding model. Okay, embedding is this. Okay, no issue. We also pass the collection. I don't need this text. Okay, yeah, just remove here, no issue. Okay, also, and what we can copy, again we would be needing a OpenAI. Okay, so just we need to write here from OpenAI, import OpenAI. Okay, yeah, and just initialize that. Okay, yeah. So okay, that's good. Now we have our embedding model, we have our vector database. Again, what we need to do, we need to take a query from user. Okay, so just take input from user. Okay, user query, interview query. Okay, that's good. Okay, now what need to do next, basically I already discussed, like we need to perform some similarity search. Okay, yeah, you can see it's suggesting me very better way. Okay, but ignore it. Search result. Okay, search result equal to, we would be needing our vector storage. Just go to that vector storage, we need to perform similarity search. Okay, just use this similarity search and pass that query. Okay, our user query, no need to k. Yeah, so using this search result we will get the relevant chunks here. Okay, yeah. Okay, we will get the relevant chunks from the db. Okay, let me just close the menu. Okay, yeah. So now we have our embedding model, we have our vector db, and we will take the query from user. Okay, and we will search a similarity search on the vector db. Okay, and we will get some response. Okay, some relevant chunks. Okay, yeah. So now what we can do, we have some relevant chunk. Okay, so we need to pass these chunks to our LLM. Okay, hi, hey, you are a very helpful AI assistant who answer user query based on the available context. Okay, retrieve from a database. You should only as the user based on the following context and navigating. Okay, yeah, so we can simple do this. Okay, so let me just quickly do that. Okay, yeah, so for that let's create a content. Okay, yeah. Okay, so from this search result, okay, I just copy it. I think it's taking too much time. From the search result, okay, we just loop on the search result. Okay, you know, we are getting the metadata also, the page content. It's okay, of course page content would be needing. Okay, yeah, the metadata like a source, labels and everything we are getting. Okay, so just loop on this. Okay, we will passing this context. Okay, so just see how I written this context equal to dot join, take that result from page content, take the metadata of source, and we are going to pass our LLM. Okay, our chat LLM. Okay, yeah. So let's create a system prompt. Okay, so for the system prompt, let's bring it here. Okay, yeah. Okay, sorry, you can see here the system prompt is, you are a helpful AI assistant who answer user query based on the available context retrieved from a PDF file along with the page content and page number. You should only answer the user based on the following context and navigate the user to open the right page number to know more. Okay, yeah, so what we are going to do here, we just directly pass this context to our system prompt. Okay, yeah, of course. Now it's last step. Okay, use this client. Okay, OpenAI client, and yeah, I think okay, no issue, just hit the tab. Okay, yeah, again we are not going to use GPT-4.0. Okay, I'm going to use GPT-5. Okay, yeah, GPT-5, and there is a message. Okay, there is a two role, of course. One is the system, okay, where we passing our system prompt, and the second one is the user query where we passing. Okay, yeah. Okay, so this is totally, I think it's a, we have completed our retrieval phase. Okay, what we have done inside here, basically we just take the lot of code from the existing indexing phase. We would be needing, like here OpenAI embeddings, we need database connection. Okay, we need OpenAI key, we need a loading.env. Okay, yeah, so here we bring our embeddings, we just bring our vector database. Okay, okay, and we get the user query, and we just pass that user query to our database and told him to our vector db, hey, please perform a similarity search. Okay, that will perform a similarity search and return us some relevant chunks. Okay, and that chunks have a lot of data, has a content, have also like a source, and have also a page number, a lot of things. Okay, we just loop on those data. Okay, because we know this a lot, we have only like few chunks. Okay, that is not a very time consuming. Okay, we can easily loop on those things. Okay, all the loop on the this search result array. Okay, yeah, so we just creating a context. Okay, and along with the user query, we are going to tell our LLM, chat LLM, like, hey, use this context and give a response according to the user query. Okay, yeah, based on this context only. Okay, yeah, so you can see there I just written a system prompt, and we just initialize our OpenAI client chat completion.create. Okay, inside we need to pass a model and a message. There is a two role. First one is a system, which will take a system prompt. Inside system prompt we provide a context, and the role uh, for basically the user role will provide a user query. Okay, using that query we will get the response, okay, from the our available context. Okay, yeah, so what we can do here, we can directly print it. Okay, just print man. Okay, have some formatted, no issue. Just I want to bring it a robot here. Okay, let's search for the robot. Yeah, okay, so we can print the response. Okay, response dot choices of 0 dot message dot content. Okay, yeah, no issue. So let's quickly run this. Okay, yeah, I think python chat dot py. Let's ready our question. Okay, our question where I open the PDF. Okay, here, so I'm going to ask like Okay, I'm going to ask a JSON web tokens. Okay, can you explain me what is JSON web tokens? Okay, enter your query. So can you explain me what is JSON web tokens? Okay, let's see what it will written. Okay, you can see here JSON web tokens provide a system for issuing and validating authentication tokens. Log this. Okay, from this lesson install this and do this. Okay, yeah. To see the details and example, open page number 81. You can see here open page number 81. It will also told me on this page number we have this information. Let's verify. Okay, so you can see this is this is the page number 81. Okay, and we are getting these things from here. Okay, yeah. So now we successfully created our chat with PDF. Okay, now okay, again it's not a for production ready. Okay, it's a very synchronous, like if we deploy this pipeline. Okay, you can see like one user if uploaded a PDF. Okay, until that PDF is not uploaded, another user cannot process their request. Okay, so this is just synchronous. Okay, yeah, a lot of things needed. Okay, we need to optimize this proper error handling. Okay, and make it asynchronous. Okay, yeah, but all those logical part, everything is completed. Okay, only the few things is remaining, like we need to add a queue system here. Okay, yeah, for the production. Okay, we need to convert this asynchronous implementation. Okay, of course we will using fast API. A Redis based queue will be used. Okay, along with the Redis for caching, and of course background task processing. Okay, yeah. So but as of now you have a working AI agent that will able to chat any kind of PDF. Doesn't matter how uh, doesn't matter the size of the PDF. Okay, you can use any size of the PDF and you can chat very easily. Okay, yeah, so that's it. Okay, yeah, thank you.